Section 1.4 is properties of real numbers. I can identify and use properties of real numbers. Big ideas here. Relationships that are always true for real numbers are called properties, and those are rules used to rewrite and compare expressions. Important properties include the commutative, associative, and identity properties, the zero property of multiplication, and the multiplication property of -1. Two algebraic expressions are equivalent expressions if they have the same value for all values of the variable. The take note on pages 22 and 23 just talks about those important properties that I mentioned on the first slide. So, commutative property of both addition and multiplication lets us move pieces around. So we can take 2 plus 3 equals 3 plus 2. We changed our order, we moved our pieces, but since all we're doing is adding, that's okay. We still get the same result. They're equivalent expressions. So anytime we move our pieces in either adding or multiplying, as long as that's the only thing we're doing is adding or multiplying all the way through, then it's the commutative property, and we can do that. The associative properties next, that deals with our groupings. So a lot of times it'll be parentheses or fraction bars or whatever grouping symbols we have. And as long as all we're doing is adding or all we're doing is multiplying straight across, we can change our grouping. We can put our parentheses in different spots so that PEMDAS says we do that part first. But again, as long as all we're doing is multiplying or all we're doing is adding, it doesn't change our overall expression. They're still equivalent. Our identity properties get us back to the identical thing we started with. So when we add, it's whatever we start with plus 0 equals what we started with itself. So anything plus 0 equals itself. Okay, we start off with something and get back to the identical piece at the end. It's our identity property of addition. In multiplication, we multiply by 1. So anything times 1 gets us back to the original thing we started with. So since it's identical in the beginning and the end, it's our identity property. That's one way to remember. The zero property of multiplication just says that anytime we multiply by 0, our product is going to end up having a result of 0. So 5 times 0 is 0, negative 300 times 0 is 0. When we multiply by 0, we'll get 0. And the last one is the multiplication property of -1, and that just states that when we multiply by -1, we get the opposite. So our product will be opposite of our original. So if we start off with 5 and multiply by -1, we get -5. If we start off with -7, multiply by -1, we get a +7, the opposite. So in example 1 here, we're going to be identifying our properties. First thing we're going to do when we check these is check and see, are all of our pieces the same on the left side and the right side? Whether they're factors, things that are being multiplied, or terms, things that are being added, we're going to check and see, are they all the same? So if we look at A, on the left we have 42 and 0, and on the right we have 0. So since they're not the same pieces, it can't be associative or commutative. We also don't go back to the identical thing we started with, so it's not an identity. Here we multiply by 0, so this is going to be our multiplication. Property of 0, or a zero property of multiplication. You can put that in the other order there if you want. In B, here, if we look, we have all the same pieces. I have a y in both, a 2.5 in both, and a 28 in both. What's changed is our grouping. In the first one, it's the y and the 2.5 together. In the second one, it's the 2.5 and the 28. So since our grouping changed, that's our associative property. Think about your associates, or who you associate with, your friends, your group of people. That is the associative property, deals with grouping. And here, because we're adding, it's going to be of addition. In C, on the left side and the right side, I have different pieces. On the left, I have a 10x and a 0. On the right, I just have a 10x. So it cannot be associative or commutative. But if we look, the thing that we start with and the thing that we end with are identical. We just added 0 to it and it didn't change our quantity. So since they're identical, this is going to be an identity property of addition. And it's of addition because we are adding. Now, feel free to pause here and give this a try if you'd like. In part A, Again, if we compare, we don't have the same pieces on the left as on the right. Here I have a 4x and a 1. On the right side, I just have a 4x, so it can't be commutative or associative. Now let's see what's happening. I started off with a 4x, and I end with a 4x. My beginning and my end are identical. We just multiplied by 1, and it didn't actually change our value. So it's the identity property of, and because we're multiplying, multiplication. In B, if we compare our pieces, I have an x on both, a square root of y in both, and a z in both. So here, I have all the same pieces, which means it's either commutative or associative. And now I check and see what changed. Well, inside my parentheses, I have a square root of y in both and a z in both. So since I have the same pieces inside the same terms, things that are added together, and my grouping didn't change, it's not associative. What it is commutative. These moved. My square root of y moved to the end, my z moved to the beginning. So when they move or change places, it's commutative. And here I'm adding, so of addition. We can use properties to help us solve some problems using mental math. So in example 2, a movie ticket costs $7.75, a drink costs $2.40, popcorn costs $1.25. What's the total cost for a ticket, a drink, and popcorn? Use mental math. So here we're looking for our total cost. And total means we're going to add these up. So $7.75 plus $2.40 plus $1.25. Now if we look at these, using mental math isn't super difficult, but it's also not as easy as it could be. If we just commuted two pieces here, meaning moved those around, now we get pieces that are a little bit easier to work with because 75 cents and 25 cents makes a full dollar. So when I take $7.75 plus $1.25, that brings me to $9 even. And now I can add in the $2.40 and get $11.40. So it's all about grouping things in a way that makes it a little bit easier. Not that we couldn't have done it the other way, but it's helpful to work smarter, not harder, sometimes. Now, a can holds 3 tennis balls. A box holds 4 cans. There are 6 boxes in a case. How many tennis balls are in 10 cases? And here we're going to use mental math. So the difference here is instead of adding these up, we're going to be multiplying. A can has 3 tennis balls, and a box has 4 cans. Each can has 3 in it. So again, we're going to be multiplying. 3 times 4. There are 6 boxes in a case, so times 6. And we want 10 cases, so times 10. When you do this, try and pick things that are going to be easy for you to do mentally. So for me, for example, I wanted to do the 4 and the 6 right away. So those are the 2 that I grouped. And I just moved my 3 here. Because 4 times 6 is 24. And I know there's 24 hours in a day. So when I take that times 3, I know that 3 days has 72 hours. And I drop down the 10 and get 720 tennis balls. And for some people, it worked easier to go straight through. They knew that 12 inches, for example, is a foot and 6 feet is 72 inches. That works. However you can get there. Okay, so whatever's easiest for you. But again, with mental math, the idea here isn't that you can't use can't write down anything, but what I don't want is like 3 times 4 times 6, carry the 1, and go about it that way. Okay, that's what we're trying to avoid. We want to try and group things in a way that makes it easy for you to do them in your head. In example 3, we're going to be writing equivalent expressions. Simplify each expression. So the first thing I'm going to do here is look at it. And PEMDAS says I have to do what's in my parentheses first. But the problem with that is that 3 times n, I can't do that until I know what n equals. So we have to change our order a little bit here. And in order to do that, I'm going to change my grouping. I'm going to get rid of my parentheses here using my associative property of multiplication, which says we can change our grouping if need be, as long as all we're doing is multiplying. Now, PEMDAS says I can take 5 times 3 and get 15, and then multiply it by n. So 15n is as simple as that gets. In b, PEMDAS says I have to take the 4 plus 7b, but again, I can't do that until I know what b actually equals. So I'm going to get rid of my parentheses here, and I have 4 plus 7b plus 8. And again, that only works when we're using our associative property of addition if everything is just being added. If there would have been multiplication or subtraction or things like that, then we would have had to change it first. Now, I can commute here and move two pieces around so that I can get things together in an order that's helpful. Because on this line, I still can't take 4 plus 7b. Now, though, that I've commuted my 8 and my 7b, I can take 4 plus 8, which is 12, and then add the 7b. On C here, remember, fraction bars are like grouping symbols. So I'm going to change my group here just a little bit so that I have a 6x and then a y. And now, remember, it's still just a grouping symbol, so I'm going to change that grouping symbol a little bit. And I'm going to take 6x times y over y. And again, when we change our group, that's just our associative property. The cool thing about this is it lets me simplify because y divided by y is just 1. Anything divided by itself is 1. And anything times 1 using our identity property gives us to the identical place we started, which is just 6x. Now, feel free to pause here and give these a try if you'd like. On A, I can't multiply inside my parentheses because I don't know what x equals, but I can drop them with my associative property. So if I take 2.1 times 4.5 times x, now I can just multiply across, starting from the left to right, like PEMDAS tells me to do, and I get 9.45x. On B, again, I can't take 4x plus 3 because I don't know what h is. So I can drop my parentheses there because all I'm doing is adding with my associative property. I still can't add though because 6 plus 4h, I still don't know. What I can do then is I can change spots. I can move things around and commute them. So 6 plus 3 plus 4h is more helpful because 6 plus 3 I can add to be 9. And on C here, I have 8m over 12mn. First thing I'm going to do is try and figure out if there's anything that they have in common. Well, I have an m in both, and I can rewrite 8 as 4 times 2 and 12 as 4 times 3. So right now I have 4 times 2 times m over 4 times 3 times m times n. I'm going to move these two pieces here, commute them, so that I can get my m's on the outside. And now I'm going to change my grouping yet again. I'm going to take my 4's as their own group, my 2 over 3n as a group, and my m over m as a group. And that works as long as all I'm doing is multiplying. 4 divided by 4 is 1. And m divided by m is 1. So 1 times 2 over 3n is just 2 over 3n. And then times that last 1 still just gives me 2 over 3n because anything times 1 is just itself. And I'm going to stop here and continue in another video.